Ooh, okay, feel better. I should probably repeat the stuff I just did. 14 questions total plus a bonus. Only 2 questions on the calculator section. Cool. Try to make this, short enough so, like, you don't have to be stressed and have anxiety while you're taking it. Hopefully it's enough, not lots of pressure so you can really think it through and show your work. Plenty of time for you to show your work. Cool. All right. Glad we did this. What is going on here? Okay, so part 1. Notice most of this test is non-calculator. Cool. Still, though, you should have your calculator charged and ready for the 2 questions on the calculator section. The bonus is on the calculator section. Homework is due Thursday. Cool. We're all in agreement. Awesome. Okay, so let's go through this. Consider this function 1/2 to the x plus 1. So step by step, this 1/2, is this going to be growth or decay? Decay, because the 1/2 is between 0 and 1. And then what about this x plus 1? What is this going to do with our graph? Yeah, left by 1. Okay, so we already have an idea of what this is going to look like. All right, so the asymptote for exponentials is always the x-axis. All right, normally exponential functions will look something like this. Exponential, if it's growth, if it's decay, it will look like this guy. So I did the blue because we have a decay. Normally our asymptote is the x-axis. Only if we have a vertical shift up or down does our asymptote move. Here, we don't have a vertical shift, so our asymptote is still going to be the x-axis, aka y equals 0. So this whole thought process we just went through, hopefully it will take you maybe 10-15 seconds to think through this. Right, if I had, 1/2, if I had 1/2 of x plus 1, so notice the placement is much different, then this would be up 1, right? That would be a vertical shift. And then I would move my asymptote up, but nope. Since it's part of the exponent, it's horizontal. Okay. State the y-intercept. The y-intercept is when x equals 0. Okay. So if I plug in, right, f of 0 is going to be 1/2 to the 0 plus 1. Well, 1/2 to the 1 is just going to be 1/2. So y-intercept is not a line, it's a coordinate. So you have to say 0, 1/2. Yeah. I think if you don't split the like this whole graphing page, I count as one question. If you 3, 6, it would be like 20 problem test. If like I'd say, oh, this is 1, this is 2, this is 3, this is 4. Still not, it's not like that long. I cut a lot from the practice test. Yeah, like a solid 6 problems. All right, domain and range. I might have forgotten to put 2 lines here, but you should say both. So what's the domain of an exponential function? I'm just going to pick one random person. Daniel, what's the domain?
Isn't it 0 to positive infinity?
That would be the range. The range is 0 to positive infinity.
So domain is negative infinity to positive infinity.
Exactly. Domain is the x. It's all x's for an exponential. The range, the y, is 0 to infinity. So an exponential, so you see how I kind of drew the graph right here. The x values are all real numbers, but my y can't get less than 0.
How did you know it's from 0 to, what would make it non-zero?
If I had it flipped over the axis and looked like that instead.
What would make it non-zero? Yeah.
If I had negative e to the x, if I had negative e to the x, it would look like this. Let's see.
Or if there was like a plus 2 out.
Would look like that. That's negative e to the x. Hold on. Nope, wrong way. I'm sorry. Flip it. Okay. This is negative e to the x. Hold on. Let me answer the first question, okay? So this is negative e to the x. If I want the domain, it's still all real numbers. My x is all real numbers, but the y would then be 0. I'm sorry, negative infinity to 0. This would be the range negative infinity to 0. Because yours goes smallest to biggest. Still, the domain for this one would be all real numbers. negative infinity to infinity. Cool. So we're going to go over logs. That's the next page, but are we good with this one? All right. Did I get your other question, Andy?
But what if there's like a +2 afterwards? Would the range
Plus 2 after? Yeah, so then I shift this whole thing up by 2. Like if it was negative e to the x plus 2?
Yeah.
So then my range would be negative infinity to 2. Or up here, if there was a plus 2 here, I would be 2 to infinity. Okay. Okay, so let's go and let's graph this. Keep in mind, this was an example. This is not part of the problem right now. So let's graph f of x. And on the test, I say, make sure you draw your asymptote. So we have an asymptote at 0. Can you see this asymptote? It's kind of hard, but whatever. So really just need, I don't know, a couple points or so. We already have one, the y-intercept. That's 0, 1/2. Keep in mind, this is the no calculator section, right? I have to be reasonable. Do we know what this looks like? We said it's decay, so it's going to be going up to the left and down to the right, something like this. Probably more like that. Something like this. I need to look at decay. And you can just label 0, 1/2. Because this problem, you don't have a calculator. I got to be reasonable. Do you know what, 1/2 to the second power, I don't know, 1/4, that's a lot of mathy math. I want to make sure you understand this is decay. Where's your asymptote? You don't cross it, roughly. Like 1, 2 points if you're feeling crazy, because I could plug in I could plug in x equals -1. If I plug in -1, 1/2 to -1 plus 1 is 0, so this point would be at 1, whatever. Like, it's close enough, honestly. I want to see decay. I want to see your asymptote and you don't cross it. You already have 1 point, your y-intercept. We're good. We can go on. That should make it a little easier. Because that's, I don't know, not the most efficient use of my time to make you do these computations that you could normally have a calculator for. I want to know, do you understand this should be decay? Okay, now we're going to deal with a log function. Ooh. So if we look, there's two things going on, all right? So we have to first decide, is this growth or decay? 3. 3, is it growth or decay? Growth. And the negative in front, what does this do? Reflects over x-axis. Now, you're not required to write this stuff, but it takes you a couple seconds. It helps you figure it out, and it shows me that you know what you're doing. Even if you get the whole page wrong, I'm like, okay, you understand something, The more work you show, the easier it is for me to give you some partial credit. That's the idea. No. The idea is you do it right, but, Lord forbid, you do something wrong, you show work. Okay, so with the log function, let's talk about growth versus decay just for a second. So if I have logarithmic decay, it will look like this, right? This is decay because we're decreasing in our y. Logarithmic growth, you're increasing in your y. I should really do it. Okay, this is growth. But guess what? We have a growth that's reflecting over the x-axis. So what will this look like? So if I flip this guy, it's going to look like it's decay. It's just you're flipping it over. Right? You're flipping. Okay, that's why I drew in the pink. So we roughly know what this is going to look like. If we want the asymptote, so for logarithms, where is the asymptote normally located? Shane, do you know? Where is the asymptote normally located for a log function? Exactly, the y-axis, which is x equals 0. So question, let's see, Andrew G, do we have a shift in our asymptote? No, how do you know? Because there's no number within the x, right? If this was log of x minus 3, if it's a horizontal shift of my log function, that means my asymptote's going to be shifted as well, but there's not. So no shift. So luckily for us, this is just going to be x equals 0. Now the x-intercept, this is when y is equal to 0. So what I have to do is I put in 0 for y, and that's just going to be equal to negative log base 3 of x. Oh man, we got to solve for x. Do we know how to do this? So first, got this negative here. What happens if I multiply both sides by negative 1? Multiply by negative 1. Oh, literally it's just going to be 0 equals log base 3 of x. And then I think I heard some people say, right, little swirly swirl, curly Q. All right, we're going to solve for what x would be. So this is 3 to the 0 is equal to x. 3 to the 0 is equal to x. What's 3 to the 0? Yeah, so x equals 1. So I have 1, 0 as my x-intercept. Intercepts are points, so it needs x, y coordinates. Think about the domain and range. All right, I want to give you guys a chance. Try it yourself. What is the domain and range of my log function? Once you're done, share to the person next to you. Question? I don't know if class. Okay.
Only when you have time.
You can go to the math center. He's open. Okay. Okay. So domain and range. One person volunteer. Yes, Rocky. What's my domain?
Domain is 0 to infinity.
Ooh, how did you know that?
Because the asymptote is on x equals 0.
Exactly. The asymptote's at x equals 0. We can't cross it. So it's got to be to the right of 0. But what about my range? Bradley, do you know the range? Exactly. All real numbers for y. Because remember, I graphed what this is going to be, right? Right here in the pink, it's circled. It's reflecting across. We know it's going to be going up forever and down forever. Okay. Did I ask about the end behavior? I don't think I did. Okay. The directions are, for the next part, is graph. Make sure you show your asymptote. So we just got to draw a little asymptote at x equals 0. And then we can draw our graph. So now I have a point at 1, 0. Am I zoomed up too far? Are we okay? Okay. So you had to like justify like what's gonna look like. You know, our question is log function, is it gonna be like this? Or is it gonna be coming down like this? All right, those are our two options. Luckily we already figured this out, but if not, you could always like plug in a number if you wanted, if you really wanted to solve what it would be. But we already figured out it's going to roughly look like this because it's logarithmic decay. So originally we said growth because the base was 3, but that negative in front of everything flipped it. Right? So originally it was supposed to be logarithmic growth. So originally it looked like this guy, but we can't have this blue boy. We got to flip it over. All right, so I'm going to rotate it 180 degrees. That did not work. Never mind. Originally it was like this. If I flip it, it will be how we actually drew it. Because that negative in front flips it over. I think that's all we had to do. So you draw your asymptote. We have a point because it was listed up above. And then I just want to see, can you justify it? If you're like, wow, I have no clue how this is going to go, you can plug in some numbers. I have plenty of space over here. But it's not wrong if you draw it just like this because you showed work for finding one of the points. And if you like list this out, there you go. Saves you some time. Yes?
When you're plugging it in, I didn't say have to be the range operation. Like, let's say you're plugging in 2, would it be like 3 to 0?
So you can plug in 2, so f of 2 is equal to negative log base 3 of 2, right? So you say y is equal to negative log base 3 of 2. So I can do okay, let me move this negative to the other side, multiply everything by negative 1. So I have negative y is equal to log base 3 of 2, swirly swirl. 3 to negative y is equal to 2. Ay, ay, ay. So it's kind of like harder when you're plugging in for x. Wait, 2? Yeah. Because then you're like, well, 3 to the negative y equals 2. It'd be better for me to plug in, it'd be better for me to write it as 3 to the negative y is equal to x, plug in values for y. Alright, so here's x, here's y. I could plug in like 2 for y. 3 to the negative 2 equals x, so that's just going to be 1/9. Which makes sense, right? It's down here. Cool. Okay, cool. Let's leave that. So you could like plug in points like we just did, but I don't want it to be too intensive. Once you understand if it's growth, decay, flipping, etc. Yeah? Because, okay. So instead of plugging in 2 for x, I plugged in 2 for y. So I like did a whole different problem. So I was like, wow, this is really hard to solve. Why don't we instead write it as 3 to the negative y equals x? And then plug in for y instead so we can solve for x. Yeah. Questions? Let's keep going. Perfect. Evaluate. Pretty sure I don't give you a problem this easy on your test. 3 to the y is equal to 27, so you see y is equal to 3. Because 27 is just 3 cubed, so you set the exponents equal. It's a nice little warm up. Yes, here we go. These are better. This is great. So it'd be nice if I could write 1/8 as 2 to some power, so I could easily eliminate it. Or you can just break it up and say, okay, let's do this part first, right? Log base 2 of 1/8 is equal to y. So 2 to the y is equal to 1/8. If only I could write this 1/8 as 2 to some power. Oh yeah, 1/8 is literally 2 to the negative 3. So this whole portion right here is negative 3. And then I can take this portion, log base 3 of 9 is y, so 3 to the y is 9. 3 to the y, okay, I can rewrite 9 as 3 squared, so you see y is 2. Plug it in here. Negative 3 plus 2 is negative 1. Hey, that's nice and easy. It's like, I would say, it's a problem like this, it's not too bad. I assume you guys know 2, 3, 4, and 5 squared. Actually, 1 through 12 squared. It's a good assumption. Think you would know like 2 cubed, 3 cubed, 4 cubed, 5 cubed. Maybe like 2 to the 4th power, 3 to the 4th power, right? So the numbers I'm choosing to put on your test are reasonable. Yeah. Cool. Let's try the next one. Does anyone have an idea how to do it? Yeah. So I can like move the exponent. Yeah, 2 times negative 7 ln e plus 5 ln e. Okay, so someone said move the exponent. Some people said cross out ln of e. So negative 14 plus 5, negative 9. Okay. You can try the next one. So this one's a little harder. I do give you a problem kind of like this on your test. So we know that, 1/10 is literally 10 to the negative 1. More or less, the way to do it, if I would have a problem like 0.00000. One more. Okay. I just have to count how many places over 1, 2, 3, 4, 5, 6, 7. This is clearly going to be 10 to the negative 7. Thank you, chemistry, for teaching us. What is it? Kids have died converting metrics. One more time? That probably would be how I die. That'd be great. Chocolate milk. I haven't had real chocolate milk since I was a baby, like a kid. Okay, so this is just 10 to the negative 7, but here this answer is just y to the negative 3. Alright, try the next one. What's wrong? You guys ready to go? What? Cool. I just want you guys to be ready for the test. I would not be sad if I would have to give everyone 100 because you just like aced this test. That'd be great. Move the exponent out front, log 7, 7. Okay, that crosses out. I'm just left with 2x. So I don't think I'll give you problems as easy as like 13 or number 9, but like if I do a little souped up version, number 10, that would be better. Like number 12, oh yeah, let me do a little harder version, but it's going to be similar. And then I give you a problem where you have to expand, I give you a problem where you have to condense, and then I give you a problem where you're solving. So really try to cut out excess. So let's expand this. Do you guys want to give it a shot first? Yeah, cool, no choice. Try it out. Give it a shot. Try out 15. So number 14 was great because you had to do multiplication on top and then the whole thing was a division. So you had like pluses and minuses, expect a problem of that caliber. Number 15 is kind of, I mean, it's okay. It's just simpler. One-third. That's a good question. Let me, right, square root of b is literally b to the 1/2. If I have like the 7th root of b, that's just b to the 1/7. Yep. So that's how so I secretly wrote ln of b to the 1/2 and then bring the 1/2 power down. Why am I doing this? You have questions about this one? No, maybe. Definitely give you one, I don't know, kind of like 14, maybe a little harder. One more step. But it's doable. You just have to like step by step. Yeah. Try to make sure you give you enough time so you can write your workout, not be, stressed. So you can write it in nice handwriting so I can read it. That would be great. Okay. Condense. ln, and I have a subtraction sign. I can just divide whatever's inside. Cool. That was too short. That's not a problem on your test. It'd be more like number 17. Give this one a shot. Number 17. I'm just making sure it's like ln of 3x over 2. It's not. I'm trying to make sure it's clear. I don't want it to be something like this because that's not equivalent. And so I try my best to be as clear as possible. Because, you know, just don't be ambiguous. I want to be able to tell very clearly what your answer is and what numbers you have. Because I will ask one other person who is by me when I'm grading the test, and I'll say, what do you think this number is? And if whatever they say, I'm like, cool, I can't read it either, and then I mark off. Yeah. If it's ambiguous, please don't make it ambiguous. Cool. Do you guys feel comfortable with number 18? Do you want to do it, or do you want to skip to number 19? 18. Okay, let's do it. Okay. Kind of hard. I wish there was a way so that like a certain base, I could rewrite both sides in terms of the same base. Any ideas? Yeah. 1/9 is just 3 to the negative 2. So I could say 3 to the negative 2 to the x plus 3. What about 27? 3 to the 3rd. Okay, now I have it in terms of the same base, and I can, you know, exponent to an exponent, simplify that. And then you just set the exponents equal to each other. So as long as you can pick the same base for both sides, it makes it a lot easier to do. Give myself enough room. Number 19, I'd like to use properties of logarithms. I have 2 logarithms on the left side, 2 logarithms on the right side, but luckily they are all ln. So if I can simplify the left side to be 1 logarithm and the right side to be 1 logarithm, and we have the same base, I can set whatever's inside equal to each other. So we have to use properties of logarithms here. I'm adding them. So I can just multiply 4 times x minus 5. On the right side, I'm subtracting, so I can just write x over 2. And then since I have the same base, right, log base e, I can set whatever is inside equal to each other. Cool. Since this is a positive number, let's see, is 40 over 7 greater than 5? What's 40 over 7? 5 and 5 sevenths? Okay. So as long as this is greater than 5, we're good. And the reason I say greater than 5 is because, oh, if I plug this back in for x and then subtract 5, I needed a positive number. So we're good, right? This is greater than 5, so we're good. So really, I only want you to like go through and show me you're checking. If you know it's not going to work, you do kind of have to do a quick check yourself. If you're done, you can try number 20. Feel like that should have been the first one, not 18. Cool. Did I not put a hard one on here? Like the Ooh, okay. So remember the last page of 3.4? How you had to take ln of both sides, like those long problems? 3.4? Yeah, I think I forgot to put one on the practice test. 100% there's one like that on your test, so. Yeah, so for instance, if this was not base 3, let's say this was like base 2. If this is like 2 to the 2x, you take ln of both sides, right? The one how we did these. Right, ln of 2, 2x. Remember how if we had two different bases, take ln of both sides, you have to distribute the ln.
This is the one where like x can be like a crazy.
Yeah, it's a bunch of ln's together. Yeah. Yeah, that's just the, I don't know, it's the way I was taught, it's the way the book like shows you how to do it. It's the way Miss Malikian does it. So I assume that's the common way of solving. Yeah, sorry for changing this problem up, but I wanted to make sure we do one like this. So technically, you could simplify this. Oh yeah. So it would be ln of 3 to the negative 8. That's the way the solutions of the book shows you, because I upload the solutions for your 3.3 and 3.4 homework. That way you can double check. And this is just ln of 3 minus ln of 2 squared. Well, ln of 2 squared is just 4, so. Oh my gosh. Oh, so much stuff to do.
Wait, why did you switch the 2x and 8?
So I need everything with an x on the left side, everything without an x to the right. What? X. I could, yeah. I'm just sometimes, you know, I have OCD and I want my x on the left side. That way I have, oh, x is equal to this whole thing. You'll get the same answer. It's just me being very, like, specific when I don't have to be. Yep. Friendly. 3 to negative 8. Distribute. If you write this answer, I will accept it. But what I'm trying to show you is like the way the book would have you do it. Also, like the way honors wants you to finish, they'd want you to keep going. Like honors pre-cal, nope, you got to keep going until it's fully simplified. Oh, yikes. I don't care. So 1/8 is a really, really big number. I boxed the answer I wanted you to put. Like, I would like you to put the box answer. Because, what?
You don't care.
If you keep going, like, that's fine, because it's correct. That's what honors pre-calculus would require you to do. But for me, I'm fine with this top line. It's the same thing. The hard part was like the whole process we went through. Like, cool, you solve for x. Okay, yep. Switch them. Oh, I need everything with an x on the left, everything with an x, without to the right. Literally just everything with an x on one side, everything without on the other. As they said, I could have just moved the x ln 3 to the right side. But I don't like having number equals x. I really want it as x equals a number, so that's just me. Okay. All right, we're good with this one. Yes. signs, yeah. Okay, let's keep going. This is a question I cut on your actual exam, so I was like, I already had you graph 2 whole things, so we can do these 2. I think we'll have enough time to do these 2. I mean, it's still important to know, but it's a lot of graphing. And I forgot to put your guys' names in the test. You'll notice the pre-calculus kids from last year I put in the test. Or my practice test. Like Jeremy. It's in pre-cal. Alright, suppose Jeremy put $1,750 into an account that pays an annual rate of 4.25% compounded weekly. Okay. How much will be in the account after 36 months? Okay, there's a lot of stuff. What is my rate? In decimal form. 0.0425. Remember, R you have to write as decimal. N, how many times am I compounding per year? 52, because it's weekly. And T, the time in years, how many years is 36 months? 3. Okay. And my principal, the amount I start out with, $1,750. Yes. And N is the number of times compounded per year. So I'm going to be using, this is money, so I have to use compounding interest. And since it's not continuous, I have to make sure to use the right equation. So, not exactly A per, but you got to use the other one. It doesn't have a nice name. A pernt, a pyre, I don't know how to say it, whatever. A parent, whatever. Because that has 1 and R and N and N and T. Okay. Plug in. So this is going to be 1750 times 1 plus 0.0425 over 52 to the 52 times 3 power. This is money, so how many decimal places? 2. 2 decimal places, unless you're a gas station and they have 3 to rip you off. All right. Yeah, don't you say like 319.9 because it's 9/10 of the next penny. Just say 320, whatever. So dumb.
Oh, is that why they crack?
Yeah. Because people are more likely to buy it if it's, $19.99 versus $20. Like, ooh, it's a deal. It's not a deal. It's so dumb. Okay. Cool, that's it. That's how much money it is. 2 decimal places because it's monies. Population. These are the ones with N. So decreasing at a rate 12 per year. So that's not continuous, right? Population things. The population is always going to be the non-continuous. Continuous literally has E. This is not continuous because it's per year. So we're going to use N equals N naught times 1 plus R to the T. N naught is how much we start with. We're starting out with 5,000 rabbits. We want to know how many remain in 2016. So the time is going to be 2016 minus 2010. So that's 6 years. And our rate, 12% per year. That's scary. That's like big time disease. That's crazy.
There's no
so if you had N equals N naught E to the KT, this is continuous, yeah. So plug in. So here it's 5,000 to the 1 minus 0.12 to the 6. So we see we should have less rabbits. We're decreasing, so it's less rabbits. We're decreasing, so it's a negative rate. I forgot to put the negative here. So I'll have 2,322 rabbits. Notice I put units because this is things. Number 25 was money, dollar signs. So if we are decreasing, we should have less than we started with. Awesome. If we're increasing, we should have more than what we started with. Now, it would be a trick question if I give you how much we ended with and you had to solve for how much we started with. Or if I say, oh, the rabbits are decreasing. If we had 5,000 rabbits in 2016, how many were there in 2010? Like, oh, if we're decreasing and we have how much we started with, how much we end with, it would have to be more, right? So that's kind of a harder problem. We could do a problem like that. Let's say in 2020 we have 5,000 rabbits. I want to know how many rabbits were there in 2010. Do you want to have more rabbits or less? Are we increasing or decreasing population? Increasing. What's our rate? By what percent?
25.
Let's be crazy. 25%. Wonderful. Okay, cool. So the rate, 0.25. The time, right? 10 years. I know n is 5,000, and I'm trying to solve for n naught. So I have 5,000 is equal to n naught times 1. We're increasing, right? Yeah, 1 plus 0.25 to the 10. So what I would do is just divide both sides by 1.25 to the 10. Because she said it's increasing. So I'd like to know how many rabbits did we start with? What is 5,000 divided by 1.25 to the 10? It's going to be a lot of, it's going to be a very small amount. Yeah, this is a problem we just made up. I need someone with a calculator. Let's go. Let's go. This is why I always go over the things before, because unreliable, I'm waiting. 537? Okay. Okay, so round to the nearest one. Wow, 10 years, from 500 rabbits to 5,000. That's a really big growth rate. It's crazy. Okay, yeah, that's it. Another variation of this problem, since we do have like 4 minutes, I'm going to show you another little variant. Let's say we start with 5,000 rabbits. I would like to know how long will it take in order to reach 10,000 rabbits if my growth rate is 5%. So this would be another variation. Okay, so I know I'm going to end with 10,000. I know I start with 5,000. I know my rate is 0.05. And I'm trying to solve for t. Ooh, this is hard. This is a hard one. This is the, how long does it take to double the population? So this also deals with kind of like half-life. So divide both sides by 5,000, right? 2 equals 1.05 to the t. Ooh, this is just like a problem we have done before. How do you get this by itself? You could take log of both sides. Here, I'm going to take ln of both sides. ln of 1.05 to the t power. Wait, I moved the t in front. Guess what t is equal to? ln of 2 over ln of 1.05. Say move the t in front. I can't move this up any further. What would this be equal to if you take ln of 2 divided by ln of 1.05? It's gonna be a long time, because a 5% growth rate to double, it's gonna be a while. Yeah? Really? Longer. Is it 14? Ooh, okay. 14 point something? 14.02? Cool. 14.02 years. So this is showing you all 3 ways I can ask you a question. I'm going to ask you to solve for the final amount, the initial amount, the time. I could ask you to solve for the rate. Ooh. Yep. There you go. You could. You'll get the same answer.